So, welcome to this lecture number 25, which will be last in this series and will continue in the next semester, which is lecture 26 on load flow studies. So, today we are talking last on automatic generation control, and yesterday we have seen why it is required, why it is necessary to control the frequency. If you do not, the speed will vary, the output will vary, and the purpose will not be served for which the motor is being used. In fact, the time will be wrong on all those synchronous clocks in the world or wherever that system is. Now, we have also seen how do we derive the model for an isolated system. There is a governor model, there is a turbine model, there is a power system model. Now, various researchers in past have given different models. A model will vary because of different assumptions. Okay. What is model? It depicts the real system to certain assumptions, and hopefully the results obtained using that model is applicable to or are applicable to the real system. That is the whole idea of doing any analysis or any simulation on computers. Now, today we will talk of dynamic response. Now, what is a dynamic response? The dynamic response is if there is a perturbation. See, the system does not remain on steady state all the time. Something or other keeps on happening in the system. Okay. So, if there is a perturbation, some change, as I told you, the load keeps on changing all the time. So, let us consider a change in load, which is very realistic, delta P d, and if you consider a step change, which is a sudden change, I am sure all of you know what is step function u of t. It is 0 up to origin or particular time instant, and then suddenly it gets stepped up, increases or decreases either direction by a particular amount a, then it becomes a u t. If a is 1, then it is a unit step function, otherwise it becomes a normal step function. Now, take the Laplace inverse of the function, and then you will get the time domain. See, the studies can be done in time domain as well as S domain, that is frequency domain. At times it is easy to work in frequency domain, at times it is easy to work in time domain. Time domain gives you, let us write down this. Time domain is realistic because things do happen in time. So, if you can work in time domain, it is wonderful, but if you can't because of mathematical convenience, then there is a frequency domain. For example, certain things are easy in frequency domain. What is a simple multiplication in frequency domain becomes a convolution integral in time domain, which is not easy to solve. So, it is easy, analysis is easy, analysis is easy. Now, what is the characteristic equation? All of you must have studied control system. Characteristic equation is the denominator of a transfer function. So, this characteristic equation, if you further analyze, you get the roots. There may be poles or zeros, and depending on that you can say whether the system is stable or not. Now, if you obtain a characteristic equation, and if it is can be approximated by first order by making certain assumptions, for example, time constant T S g is less than T t is much less than T p s. What is S g? Speed governor. What is T? Turbine. What is T p s? The transfer this time constant for power system. Now, typical values, if you want, T S g is 0.4 seconds, T 1 or T t is 0.5 second, and this is 20 seconds. That is why much less than. So, we can put these to 0. So, when you solve this and finally, if you plot the dynamic response for that isolated system whose block diagram we drew yesterday, then what you will get? This is the dynamic response, this is the time, and this is change in delta f frequency. Now, as you can see, it reaches a peak, overshoot, comes back, after some oscillations it settles down to new steady state. So, if it started with 50 hertz and if it settles down to 49.5, then there is no problem, we are safe, and we say system is stable. Now, what is the control area concept? Control area concept. Yesterday, if you recall, we were talking about coherent system. That is a system in which all the your generators swing together, move together, behave in similar way. So, if you can examine one, you are as if you have examined all. Similarly, there is one area, that is a Delhi Electricity Board or DVB, or what is that, is our control area. We are really not bothered what is happening in Haryana, what is happening in Rajasthan, all neighboring states. But if you are interested in all those things, then what happens? This is Delhi, this is Haryana, this is Rajasthan, and this is UP. These are the 4 or 3 neighboring states, UP, Haryana, Rajasthan. It is surrounded by these 3 states, but they are interconnected. You can't say this Delhi is completely isolated. We do get power from Bhakra, we do get power from Haryana, we get water from Haryana. So, it is all interconnected, but we can as well study Delhi system alone if you want to, because that is our system. But in case you want to study the whole big system, then you can use the principle of equivalencing. This is being done in practice every day. What is equivalencing? In order to reduce the order of the system, reduced order modeling is a very important technique in control system. So, what you do? You reduce the number of buses in Rajasthan, Haryana and UP and bring their effect to the boundary of Delhi. So, that becomes equalized system, reduced order system, and then the number of buses are reduced from 100 to maybe 20, and it is easier to analyze 20 bus system. Why? Because if something goes wrong drastically in Rajasthan, Haryana or UP, definitely the effect will be felt in Delhi. So, we must analyze these 3 boundary states. What are different controllers? This topic is very important. What are different controllers? One is proportional, PI, PD, PID, and then let's say intelligent control, intelligent control, or we call it smart control, or robust control, adaptive control, and variable structure control, No, I don't want that lag lead here. So, variable structure, stochastic, and then we have evolutionary genetic, optimal. These are the, we can have fuzzy control. These are the various controllers used in not only electrical engineering, in any system, be it medical system, be it biomedical, be it naval, air, anything in life in the world. These controllers had to be used to control certain things. We have to control the direction of the missile. Rather than going to enemy country, it should not land in the friendly country. So your target has got to be hit, and that is why these controllers are very important in life. Now each control has some positive point, some negative point. So to choose a controller is not an easy task, like choosing a medical, a biomedical doctor a medicine. Even if you have a cough, all of you may be given a different medicines. It depends whether you will react to particular medicine. It depends what are other complications. It depends whether you are a diabetic. It depends whether you are a hypertension, having hypertension. So similarly in system, we have to see system is used for what? What is there to be controlled? Is it an exact control? Is you want local optima? You want universal optima? You want global optima? What are the different constraints? What are the effort required? What is the time in which you have to control it? So all these factors make life very, very complicated, and choosing a, that is why no single control can be said is an optimal, is the best for all situations. And that is why all these controllers are equally important, because it depends on circumstances which one, there is neither a time nor necessity to study all of them in detail, because you must have studied them in your control course. However, in this particular topic we will talk about proportional and proportional integral, only two controllers. So for LFC, that is load frequency control, or AGC, that is automatic generation control, both are used interchangeably. Okay. Some people use ALFC also, automatic load frequency control. If you use PI control, what is the advantage? Delta F steady state S times delta Fs, as S tends to 0 is 0. I am sure you must be recalling your initial value theorem and final value theorem. This is what we are using to find out the final value of deviation, and this must become 0. Unlike the diagram I have drawn earlier, it is not becoming 0, it is settling to a new steady state. What I want? I want it to be like this. This is PI control, and this is without integral control, it is only P. I am interested in, then I want this steady state error to be 0. In this case it is 0.5 hertz. So this 0 is only possible if you use PI controller. Now I have mentioned to you in one of the earlier lectures regarding load dispatch center or energy control center or power system control center. What is going on in this center? Different studies are taking place and different time frame. For example, load forecasting is not load frequency control, this is load forecasting, is going on all the time, very short term, middle term, long term, very long term. What will be the load in India in 2050? I am interested. What will be the load in 2010? I am interested. What will be the load in 2004 and that is 13-14 months hence? I will be interested. What will be the load tomorrow? I will be interested. What will be the load at 11:30 p.m. today? Now it is 11:26, not a.m., not p.m. 11:30 a.m. I am interested. That is very short term. So I have to run maintenance scheduling program, unit commitment program, economic dispatch program, and LFC, load flow. All these various functions are being solved all the time by engineers sitting in load dispatch center. Here you can get information from whole country, whole system, and we use SCADA. What is SCADA? Supervisory control and data acquisition system, using modern computer knowledge. If you feel state estimation, you can add to this list. You can also add security analysis essay. Now, what is state estimation? The data may be spurious, may be corrupted. Now, how do you remove the corruption in the data? How do you make data pure? That is called again a filtering. Suppression of spurious data and getting the correct data, that is the estimation. News comes, the government has to filter out what is the correct news and what is the rumors. Same thing happens in power system. The methods used are least square estimation technique. Okay, we want to minimize the error. Now, what is security analysis? Security analysis was started for the first time by a gentleman called D. What does he do, or what did he do? He divided the system into 3 parts. This is the normal state, this is the alert state, this is an emergency state. Now, from normal to alert you can go. Suppose you are normal, your temperature is perfectly all right, blood pressure is okay, pulse is okay, and suddenly you feel that there is a cough and cold. So, cough and cold is alert. You immediately go to doctor or to a nearest medical shop, purchase some tablets, some Navalgene or Action 500, depending on what you are used to, or Jandu balm, and you try to apply yourself, you take a corrective action and you try to go back to normal state. But if you happen to take a wrong medicine, or if you happen to go on eating chola bhatura and samosas, dirty oil, then you land up in emergency rather than going to normal. So, cough and cold get converted into fever, high fever, lot of cough, bronchitis, and maybe there is a problem. If you do not properly take precautions, something will happen. What will happen? Blackout, collapse, system collapse, and then 18 hours no power in United States, Canada, France, India. In order that not to happen, still there is a time the load dispatch control people do something and they try to go back to normal even without going to alert. Special injections, ICU, operation, and you come back to normal. And sometimes you go from directly to fever, so normal to emergency without coming from cough and cold route, or you can go back from emergency to alert and then alert to normal. The Tata Electric Company is the best private electric companies in India. There was one Dr. R.K. Pandit. He was the Director General of that company. He was delivering one keynote address, and there he said, in India the power system lies in normal state only 28% of the time. It was a shocking statement. How do you feel if you remain healthy only 28% time of the year and remaining 72% of the time you are sick? Do you have that much sick leave? Do you have that much medical leave? What will happen to lectures? You will miss the lectures, you will miss the minors. So, how do you have mechanism, some strategy, so that it remains in normal state 72% rather than 28%? And for that you need to carry out all those studies, and this is a very serious affair, because now our installed capacity is 105,000 megawatt, multiply by 4 crores. How much money is involved in this operation? No power, no industry will run, no production, the economy will be down. So, our job is to keep the wheels of the industry running all the time. How can that happen? Provided you supply the power, forget about quality supply, you have to supply some power, and then the quality can be improved by the consumer. That is the era which has come. It depends on you how much you want to boil the milk to make it rabdi. Okay, it is up to you. So, that expenses is yours, that gas expenses or time expenses. The house lady has to stand there or whatever. So, the quality power supply is a distant dream, when it will be absolutely 50 hertz, 220 volts, no harmonics, THD is less than 5%, total harmonic distortion less than 5%. So, that is the quality, power quality or energy quality. Now, this is the security analysis. Now, security analysis, you do contingency studies. This is not contingency which you get in your scholarship, 10,000 or 30,000 or 20,000 or 5,000, whatever you get, I do not know. Contingency analysis is another important topic in power system. Contingency is nothing but, what is contingency? In fact, that is same meaning here also. You are given that money to provide for any typing, any xeroxing, that is a contingency which has arisen. Here contingency means fault, series fault, shunt fault, open conductor, line to ground, line to line, line to line to ground, all line grounded. So, assume different type of faults and see whether your system remains in normal state or not. Suppose there is a power system. Now, there is a fault here. Will this line be strong enough to carry the requisite amount of power to supply these loads, at least temporarily, till you clear out this contingency? So, this is contingency analysis. Can you bring in some power from somewhere else here to compensate the loss here? This is what you do in contingency analysis. Now, if you consider all contingencies, you will go mad, because in 100 bus system, in 1000 line system, permutation and combination you must have studied in your 6th class or 7th class or whatever class, NP, R, NC, R, there are several permutation and combination. So, contingencies can occur in a different fashion. Anyway, so contingency can occur in a different way. They won't announce that, hey, I am coming tomorrow, fever, I am fever speaking. You suddenly get up in the morning and you feel you are not well. So, there is no warning given by them, right. So, what do? We rank the contingencies. The most hopeless, most critical contingency is number 1. Examine that, and if you feel you are safe, then naturally you will be safe for remaining contingency. If you can have 1000 rupees any of your spouse or your brother needs 100 rupees, there is no problem. Once you are taken care of 1000 rupees, 100 rupees is no problem. So, that is called contingency ranking problem, which is very important in power systems. The last resort is load shedding. Suppose you cannot get power from any source, then you have to shed the load. Load shedding is a genuine control mechanism to circumvent any fault, any contingency. But which load to be shed? Not the way it is done in India. Okay, close host cars, close green park. This is done in an ad hoc manner. This is the only country where the traffic control is an open loop control. Red light and green light is closed after 2 minutes round in a round fashion, without bothering whether somebody is there or not. It should be a function of the traffic. Suppose there is no traffic there, then why should you have a green light? Nobody to go. You have red here, and if that road is having lot of traffic, have green there rather than having green here for 2 minutes. It happens. It may not happen in Delhi, but it happens in so many places. So, you have to have a load shedding also in a style, by some mechanism, by some algorithm, by some formula, how much load to be shed and for how long. This is a very important optimization problem, and someone of you should take it as a MTech thesis, because it is very much relevant to our country, because we have load shedding all the time. There is no city in India where you get power for 24 hours, not even Delhi, no Bombay, except Bombay. Bombay is a different world. Bangalore, Hyderabad, Calcutta, everywhere there is a load shedding varying from few minutes to few hours to whole day. Okay. Now, the dynamic response should be fast. How do you make this dynamic response fast? If you get 49.5 hertz after 1 hour, what is the use? I want it to achieve that figure. I do not want to go through again back to that figure. That 0 state steady error should be achieved less than 20 milliseconds. Less than 20 milliseconds, then it is called fast. A second is a very big time in power system. So, it should be in milliseconds. Now, it is the era of nanotechnology, nanomaterials, nanophysics, and a bio, of course. I was talking about yesterday, if you recall, GRC, generator rate constraint. The load frequency control problem discussed so far does not consider the effect of restrictions on the rate of change of power generation. You can't make it in a like a gin in a second change. You want 50 megawatt, okay, 50 megawatt. You want 30 megawatt, okay, 30 megawatt. If that would have been the case, no control is required. If you can switch on and switch off any amount of megawatts, where is the problem? Unfortunately, the reality is not so accommodating. It is different. So, rate of change of power generation. Suppose we have a steam plants. As you know, we have 72% is steam power plant, thermal. They are also called thermal, maybe coal based mostly. Now, you take always a considerable amount of time to start a thermal power plant, and that is called lead time required. If you ask your driver to bring car, you won't bring it in second. You say, sir, I am going to the garage, wherever the garage, even if it is in your house, you used to go open the lock, open the car. Nowadays there are 3-4 locks in the car. You have to open all those locks, you have to sit there, so start, come on the road, it takes 5 to 10 minutes. It cannot be instantaneous. Similarly, if somebody wants power in the afternoon, then only you have to start running the thermal power plant right now, 11:42. Then you can get power perhaps by 5 p.m. or 4 p.m. depending on when it was shut off last. Suppose it is absolutely cold, and even coal is also not pulverized, then God is the answer. He also cannot do anything. So, it depends what is the current situation. Is it a cold startup, it is a hot startup, or is already spinning reserve, where you can do it perhaps as early as possible. The generation rate from safety considerations of the equipment for reheat units is quite low. Most of the reheat units have a generation rate around 3% per minute. What is reheat unit? There what you do, you have a turbine, I have explained you earlier also. You take out steam and pass through reheater and again bring it back. So, it is a recharging the battery. Your superheated steam has lost some of the steam, as you call it, and then again is a reheater, pass through that, and so this generation rate constant is 3% per minute. Some have a generation rate between 5 to 10% per minute, not more than that. If these constraints are not considered, system is likely to chase large momentary disturbances, which you should avoid. This results in undue wear and tear of the controller. I have told you earlier also in power swing. Several methods have been proposed to consider the effect of GRCs for the design of automatic generation controllers. When GRC is considered, the system dynamic model becomes non-linear. Whenever the model becomes non-linear, people get worried, because the non-linear analysis is not easy. A linear analysis is lot easier, and so people always linearize the system and get the results, and which should be fairly valid. Otherwise, there is no point in linearizing the model if you cannot linearize it. And linear control techniques cannot be applied once it is a non-linear, for optimization or controller setting or anything. Naturally, the system order will go up from second order to third order to fourth order. The higher the order, more difficult to solve the system. Sometimes it is better to consider it as a constraint rather than a variable. For example, water storage in a reservoir, once you get an answer, see whether it is more than x max or x min. If it is more or less, fortunately it cannot cross both the constraints simultaneously. Either you are inside the studio or you are outside, you can't be both, only God is omnipresent. So, at a given point of time, any variable either can cross upper limit or lower limit, not both. We are saved. If it would have been possible to do both, then we would have been soup. Fortunately, no variable can cross its limits upper and lower simultaneously. So, it is better to check this algorithmically rather than bring this assumption in the formulation. So, what you will see? You will see that whether the generation rate constraint is obeyed, then there is no problem. Then you do not have to alter the order of the system. What is deadband? I talked to you yesterday about deadband. The effect of the speed governor deadband is that for a given position of the governor control valves, an increase and decrease in speed can occur before the position of the valve changes. It is not able to keep track, there is a time delay. The governor deadband can materially affect the system response. The deadband effect indeed can be significant since relatively small signals are under considerations. The speed governor characteristic is of course non-linear, you have seen that diagram, and we definitely approximate them by linear analysis. So, this is another non-linearity introduced if you consider deadband. Mechanical friction and backlash and also wall overlaps in the hydraulic relays cause governor deadband. Speed governor may not immediately react until the input reaches a particular value. It is like a no load current which you have to supply to keep a motor running at no load. If you are talking on your scooter or your bike and this is on, it is not moving, yet it is consuming the petrol, because you thought you will finish your talk in a minute, but you have been there for 5 minutes. Indians anyway talk too much. So, it is better to put it off, but then who will kick it again? That is the problem. People do not want to do any hard labor. So, they keep on continuing to have it on, which is very bad, against the principle of energy conservation. So, deadband can be also considered in the model, make it as complicated as you can, and that becomes a very important and complete model if you consider GRC as well as deadband. Well, many people have already considered. There have been 5 PhD theses in this institute on load frequency control. One is Prof.D.P.Kothari, one is T.S. Bhatti, one is B.L. Kaul. B.L. Kaul is the principal of a private college in Noida. You can go and have a job with him if you want, and 2 more. One is in NREB, Prabhat Mohan, and so on. So, you can have a go at their introduction or summary of those PhD theses. I do not want you to read the whole thesis, just read the synopsis to get a feel how those guys have done in improving the LFC model. Digital load flow controller. Now, everything is digital now, digital camera, all digital, there is nothing analog. In recent years, more attention is being paid to the question of digital implementation of AGC algorithm. Digital control turns out to be more accurate, more reliable, more robust, compact, small, less sensitive to noise, drift, and more flexible, all plus points. It may also be implemented in a time shared fashion. Now, time sharing, multitasking, parallel processing, these are the mantras of present day. You have to do it. You go on opening windows on your PCs, you go on seeing Naukri.com and etc., so many sites which are not supposed to see also you see, etc., etc. The ACE is automatic control error. A signal which is used for AGC is available in a discrete form. There occurs sampling theorem, you must have read sampling theorem. At what rate you should sample, that is very important in anything digital. In fact, in practice you can't judge in a factory all the Coca-Cola bottles that are coming. You take samples and feel satisfied, oh, quality is excellent. So, sampling has got to be done. The digital control process is inherently a discontinuous process, and the designer has thus to resort to the discrete time analysis for optimization of AGC strategies. That means, instead of differential equation x dot is equal to A x plus B u, you have to use difference equations, which you must be aware, you must have studied in your earlier classes, and you will have x k plus 1 is equal to phi or phi times x k plus psi times u k plus gamma times p k. Disturbance variables are also there, besides state variables, besides control variables, besides your independent variables, you have disturbance variables as well. Then you can bring stochastic by having either the white noise or colored noise. I do not know whether you have studied these things. The white noise has 0 mean and it varies around that normal distribution. I am sure you must have studied the normal or Gaussian distributions. This is minus 3 sigma to plus 3 sigma, and this is the mean value. What is decentralized control? So far we have been talking about digital load flow controllers. Now let us talk of, let us change the color. Change the color has a different connotation. This is very faint. Let us see this. Yes, this is okay. Decentralized control. Now they talk of transparencies, they talk of openness in life, and they also talk of decentralization. All powers need not be with the boss. The power should be decentralized, some to DD, some to deans, some to heads, some to in charges, so that decisions can be taken fast without any interference from the top. TQM, total quality management. What we have in India is NQM, no quality management, NO, no, not even LQM, low quality management, it is a no quality management. Anyway, in view of the large size of the modern power system, right from Srinagar to Kanyakumari and Kutch to Agartala or whatever is the last point in northeast, it is virtually impossible to implement either the classical or modern LFC algorithm in a centralized manner. You cannot have a LFC for whole India. A decentralized control scheme is always preferred. As I said, let us only control Delhi, and if you want to include the neighboring states, because you are connected to them. The reality is Delhi is not an islanding, the power system islanding you must be knowing. So you can't create islands, it has to be interconnected with the, in fact now we are going for international grid. What is the advantage? When India sleeps, US works, when US sleeps, India works. So that all that power can be transmitted to India from US when they are having night, and all power from India can be transmitted through satellite, through whatever link, through whatever may be wireless or whatever less, it is possible. It is no more a fiction, it is going to be a reality. There are already their offices are operating in India and US round the clock. They have an office in Gurgaon, all US firms. The Gurgaon secretary speaks English again in an American accent. You will never know from where she is talking. She is sitting in New York or in Gurgaon, the client will not know. And so the now US firms are operating round the clock. There is only 2 hours in time which is overlapping in US and India, otherwise it is night there, day here, day there, night here. And so imagine they are on the pulse of the world for round the clock. For them it is, and the payment is 1/3 of US, and the work is perhaps better than US. So most of the US now are going to have offices, work done, outsourcing, another mantra of today's era, and they want to work in India. Anyway, this is nothing to do with LFC. So, if there is a system, maybe it is whole country or whole world or whole Europe, whole continent or SARC or whatever, this is controller 1. This is U1, this is X1. Similarly, you can have more than 2. I am just explaining you the principle. Controller 2. This is decentralized control. Now, these two are not in talking terms directly. This may be France and England, but there is this, this system is being controlled independently by C1 and C2. The information is fed to C1, C1 gives you control, information is fed to C2, C2 gives you control. This is U2 and X2. So, it is decentralized control. The C1, C2 are not at one place, okay, and this is now being operated. Now, other techniques of model simplification are available in literature. Alternative tools of decentralized control are also available. Aggression analysis, I do not know whether you heard about it, singular perturbation, moment matching, and so many other techniques are given in the literature. If you have a time, if you can, unless until you only want to download everything. No, you have to not only download, you have to go to library and read literature. Downloading, you may not get everything. This can only be a help, but not the only way of learning sitting in front of the PC. I think with this we finish today's lecture. Any difficulties, any clarifications or anything? If not, then we will see you on 26 for the final. I am immensely enjoyed your company for the whole semester. We have had a very pleasant time, and I wish you all the best for all the exams that you have in this semester.